If we apply an alternating potential difference across any two conductors whose spacing is large compared to their diameters, then the air surrounding the conductors experiences an electrostatic stress. At low voltage, there is no change in the condition of this atmospheric air. But whenever we slowly increase the voltage through these conductors, then a violet color's faint luminous glow appears on the conductors with a hissing noise. This phenomenon is called corona. Corona produces ozone gas which can be detected with its characteristics smell. Now, if we want to discuss the factors affecting corona, then these are the basic factors which actually has an impact over corona. If we try to discuss the factors individually, then we can get atmospheric condition is a prime factor for corona. The basic requirement for corona formation is ionization of molecules. Now, which molecules? The air surrounding the conductors. This phenomenon is actually more predominant in stormy weather compared to the clean weather, because in stormy weather conditions there is more ions or ionized particles are actually available in the atmosphere. This helps to formation of more ionized particle, because this formation is actually done by the bombardment of molecules and dislodging electrons. Because if we consider a conductor and its surrounding air, the voltage across the conductor, or me use a different color, the voltage of this conductor is actually creating pressure to this surrounding air for the formation of corona or creating ionized particles, ionized molecules. So if we get a stormy weather like this, then the formation of these ionized particles would be easier to form the corona compared to the clean and normal weather. Next is conductor size. To understand this phenomenon, we need to understand a special term called disruptive critical voltage. If we take the simple expression of this disruptive critical voltage, that is VD, we will get GR ln D by R, where D is your spacing between the conductors, G is potential gradient, and R is the radius of the conductor. Now, these two factors are actually possible to understand using this equation. See, if you are increasing the conductor size, that means you are actually increasing the radius of the conductor. If you are increasing the radius of the conductors, that means you are increasing the critical disruptive voltage VD. Now, what is critical disruptive voltage? The voltage at which corona occurs. That means the voltage at which the surrounding air breaks down to form corona. Clear? Now, if we are increasing the size of the conductor, or better to say the radius of the conductor, then we are actually the voltage level or the critical disruptive voltage. Now, in transmission line, the voltage is a fixed voltage. It is not much variable. So, if you are increasing the breakdown level of the voltage, the transmission line voltage is not sufficient enough to break down the surrounding air, so that you will never get the corona. Similarly, if you are decreasing the radius of the conductor or size of the conductor, then VD is decreasing, because VD is proportional to R according to this equation. So if conductor size decreases, then corona formation would be easier as the critical disruptive voltage is decreasing. Clear? Now the spacing is your D. Now if you are increasing D, the same thing is applicable here also. So the same explanation is also applicable for your VD and D situation. So conductor size and conductor spacings are two prime factors which are actually affecting the corona. Now we are coming to the last point, that is your voltage level. In a transmission line, if your transmission voltage is enough high, then it will meet to the value of this critical disruptive voltage and break down the surrounding air, so that the corona formation will be easier. Now if your transmission voltage is not enough high, then it will not able to meet this critical disruptive voltage value, then the corona formation will not be easier, because the electrostatic stress over the surrounding air will not be enough to formation of corona. Now the same concept is applicable for reducing corona. See, what is our objective? To increase the critical voltage level. Why? Because if we can increase this critical voltage Vd, that means we are increasing the value of the breakdown voltage or at which corona occurs. So to avoid corona or to reduce corona, we need to follow the same procedure by which we can increase the value of Vd. If we can increase the value of Vd, then automatically corona will decrease, and to increase Vd we have to increase the conductor size, that means the radius of the conductor or the diameter of the conductor, and the conductor spacing, that means the distance between the two conductors. And following this method we can reduce the corona effect. But what you really need to understand or have to keep in mind that we cannot increase the spacing into an infinite level, okay, because to increase the spacing after a particular level you have to introduce the broader cross arms, so that will actually increase the cost of the transmission line, okay, this like the cross arms. And similarly you cannot increase the conductor size into infinite diameter, because that is not also economically cost effective. So you have to, as an engineer, you have to manage the entire process that will both economic and causing less power loss. Okay, now advantages and disadvantages of corona. Now we will going to discuss the advantages of corona. Due to corona, the conductors of the transmission line produces electrostatic stresses to the neighboring air, and dislodging electrons from this air creates it conductive or does a lot of ion formation. This actually increases the virtual diameter of the conductor. That means the entire region is becoming a conductive region. Now what is this advantage of this phenomenon? This is reducing the electrostatic stress on the surrounding air and improves system performance. Now you will ask, how does it possible? See, whatever you have studied in your physics is electrostatic stress E is equal to minus dV dr, where V is the voltage and R is your radius of the conductor. As the increase in virtual diameter in any way increase the value of R, so the value of E is decreasing, as E is inversely proportional with R in this equation. That is why it is decreasing the electrostatic stress on the surrounding air, and simultaneously the chances of flashover is reduced. Clear? Corona reduces the probability of lightning surge on the transmission line. Now the question comes, how? As I have discussed earlier, due to corona, the neighboring air experiences electrostatic stresses, so that there is ion formation of the neighboring air. This is increasing the virtual diameter of the conductor. Now these charges are reducing the potential difference between the cloud and the communication line, because these charges are discharging the cloud charge, which is responsible for lightning. So this corona is actually reducing the cost of lightning gears of the transmission line. So it is another advantage of corona. Corona effect causes a certain amount of power loss, though this is only possible in the abnormal weather condition, as the corona effect is not visible or occurs in normal conditions. Corona causes the interference with the neighboring communication system due to its electromagnetic or electrostatic stresses. As corona produces ozone gas, so that there is a corrosion of the conductor due to the corona effect. I hope the corona concept is clear to you. For any doubt, do mention in the comment section. Thank you.